because you need to have the whatchamacallit, you kind of need the questions in front of you, because I don't have the typed questions up in front of me, okay, or up on somewhere where you can see it. I kind of wrote notes down, and I'm going to work off of those notes. I'm going to read, though, from the typed questions, okay? I have to do that because College Board does not allow us to actually post the questions and post them online. I can post a link to them, but I can't actually post their questions because of copyright issues, okay? All right, so we're going to get going. I've got new, fancier things that I'm using these days. Okay, so I am going to, I got more colors than I did in class. It's super exciting for me. All right, so I'm going to start with 2017, number 1. These are calculator questions. We don't have to, what do we do if we can't see the screen? Is everybody not seeing the screen? If you can see the screen, raise your hand. My little screen where I put the problems. All right, so it looks like a lot of people are seeing the screen. Try hitting the 3 dots in the bottom right-hand corner, okay? So if you can try hitting those 3 dots and see if that makes it better, okay? All right, so I'm going to do the 2017, the number 1. It does say that it's an ABBC problem. Okay, it is a calculator problem. It's not going to be a calculator this year. So when there's calculator parts that we need, we're going to probably just kind of gloss over the answers. I'm going to show you the processes more than I'm going to show you the answers. You can leave it numeric, okay? And those of you that have been watching hopefully the College Board videos have just noticed that you can leave it just as like 6 + 7 + 8 + 9 + pi, okay? I picked on ones that have Riemann sums in them. That doesn't mean that the entire problem is Riemann sums. So when you do a free response problem, you're going to see that it's going to have a lot of different things in it. And this year it's going to have more than ever in question 1. Okay, so we have a good old table there. You know, if there's a table, there's going to be some kind of Riemann sum in it. Hello, Jasmine. So you know that it's going to be, I highly guarantee they're probably going to put this on probably one of the 2 questions, okay? Because it's almost there every year, and it's easy to get a lot of stuff out of this table. So the question reads, a tank has a height of 10 feet. So that's what I wrote right there, and I want a different color. Okay, height of 10 feet. The area of the horizontal cross-section of the tank at height h is given by a function a, okay? A of h is measured in feet. So this, remember, this is acting like an x value, because look at where it is in the table. This is acting like a y value. Look at where it is in the table, okay? The function a is continuous and decreases as h increases. So that's what we wrote down right there. I wrote it down because I didn't know if it was important or not when I was reading through the problem, so I thought it might be important information. We're supposed to, in part A, use a left Riemann sum with 3 subintegrals indicated by the data in the table to approximate the volume of the tank. All right, I know for BC it's been a while since we've done some Riemann sums, so this is good review. It also says indicate units of measure. If it says indicate units of measure, you need to put it down. There's going to be points for those units of measure. All right, so I'm going to go to my table, and I'm going to divide it into my 3. Okay. And we know it's a left Riemann sum, which means I'm going to start with values from the left. So I know it's 3 subintervals. I'm going to make space for 3 subintervals. Okay. Hello, David. All right, so I know that I have to multiply the distance in between, and I'm going to use this height here first. So my first distance in between is 2, and the height is 50.3. My next distance in between is 3. And my height is 14.4. My next distance in between is 5. I wrote too many plus signs, sorry. And my height is 6.5. I've run out of plus signs and space. I'm done. That is actually your answer. You get to stop there, okay? You do need to label the units of measure. So the units of measure indicate units of measure. So we would have to go here. Remember, it's your y's over your x's. Okay. So in this case, my y's, and this one's weird because it's in feet and feet. So it'd be feet squared per feet, which is really the same as saying feet cubed. So again, you can leave your answer here. Stop here. Okay. However, for those of you that's bothering, and you really want a number, you can, it was 176.3 if we actually went through the calculator and calculated that out. Okay. All right. We good with part A? All right. Let's look at part B. We need to decide if this is an overestimate or an underestimate. And we have to have a reason, okay? And we practice this. We have to talk about this table here, okay? So we have to decide if the values in this table are increasing or decreasing as we are getting, as my X value is getting bigger, what's going on with these Y values? Well, it goes from 50 to 14 to 6 to 2.9. So I know that that's a decreasing function. So this is where we learn to draw all these pictures. It's a decreasing function, okay? So, and then I know it was a left Riemann sum. Ooh, stuff disappeared. A left Riemann sum. So I'm coming at it from the left, and if I start drawing my little rectangles, this is why we practice all that, I know that I can definitely see that that is underneath the curve. So this is an, oh, wait a minute, what happened? I was totally wrong. I drew it wrong. Sorry, I'm looking at my answer key. Let me draw that again. Let me choose two different colors. So this is that. Okay, so I'm coming from left. Yes, I was totally wrong. It should be like this, like that over, because you're going from this height here, that spot there, over, that spot there, over. So it is an overestimate, okay, because I drew it wrong. And there's two reasons of that. So we would say that this is, let's write a nice sentence, approximation in part A is an overestimate, okay, because a left Riemann sum, a left Riemann sum is used and A is a decreasing function. Okay, I'll give you a minute there to get what you need. Okay, so now let's go ahead and look at part C. So part C says the area in square feet of a horizontal cross section at height h is in feet is modeled by the function f. And so they gave us this function here, okay? Based on the model, find the volume in the tank, indicate units of measure. I don't think this is going to show up on AB. It doesn't hurt for you guys to listen to C and D. I don't think these are, some of the D, there's going to be a part of the question would be an AB thing this year. In previous years it was. I'm not sure on part C, so we hadn't quite got to this stuff. We had talked a little bit about position, velocity, and acceleration. So let's talk about that again, okay? So we've got position, velocity, acceleration, okay? As we do position, velocity, and I know this has nothing to do with this, but this is how I think about it, okay? So we know that this is F. We know when we take the derivative, we get to F prime, and we know when we take the second derivative, we get to acceleration, okay? So as I go down this, I take derivatives. So if I have position and I want to go to velocity, I know I got to take a derivative. If I'm in velocity and I need to get to acceleration, I know I need to take a derivative. But we can reverse it as we go up. So if I'm in acceleration and I need to get to velocity, I have to integrate it. Okay, so that's the opposites. So I think of this the kind of the same way. If I am in, I think it goes volume, area, perimeter. So this is why I showed it to you that way. So if you could remember that order as well. So as I'm going up, I need to integrate. As I'm coming down, I need to take the derivative, okay? So we are in an area situation. So this was supposed to be area. They want me to go to volume, which means that I'm going to have to integrate that. So we would just set up an integral. So we would write the integral from 0 to 10. And then it's a named function, so I don't need to write the whole function out. You shouldn't, because you might make a mistake writing it down, plus it's a time sink. So integral from 0 to 10 of f of h dh. Okay. Now, on the test this year, it will be something that you can integrate by hand. There's no way we're integrating that by hand. We would have used our calculators. I'm not going to go into that part today. So this part here would be actually worth a point. So doing that setup would be worth 1 point. Okay. And then finding the answer with the calculator or something with a simpler function by hand would be worth a point. So the final answer on this one was 101.325. And then we had to label it. Volume is always in something cubed, right? So in this case, the problem was all in, oh, I think they say it up here, it's in feet, right? So it would be feet cubed for volume. Okay. All right. Again, if you've got a question, you got to let me know. Raise your hand. I'll kind of watch, and then if somebody in the chat has a question, let me know about it. Okay. All right. So this one here, the way it's set up in Part D, we did this in the AB class. Okay. And the way I presented it in AB last year is different than the way I presented it this year. Okay. So I don't want to say that. This particular problem the way it's phrased wouldn't be on the AB test this year. It would only be on the BC test. But the phrasing and the words could end up on the AB test. So it's good for you to watch. Even though there's going to be some parts of it, AB kids, don't get bogged down in it. Let's just worry about the setup, and then I'm going to go through the whole problem for the BC kids. Okay. So first of all, the problems, and I wrote a little bit more of it because we need a little bit more of it for this to do some of the stuff we were doing. So if you're in AB, remember the words of the equation. Those notes, those are going to be super important. There's going to be stuff about rates on this test. Okay, 100% guaranteed. It's a very easy thing for them to, you're not be able to put it into the internet, and it's a very thing that you can do, and you have to understand the concepts of it. So remember we had some sentence frames that we were doing. We said something like at t equals a number, and I know for the BC kids this is kind of something that you might not have seen in this way. We've done it, but in a different way. The words of the equation, so this is to justify your answer, okay, is, and then it's either increasing or decreasing, okay, and then at a rate, and then you want the answer, you're going to fill in the answer with the units, okay. So that's kind of what our end is going to look like, sort of. It's not, in this particular case, we're not going to have a t there, okay. So this one, they tried to throw a curveball in here, okay? So this was Part D. It is possible to do this part without doing any of the other parts. And notice, it's not Riemann Sum, okay? So we need to, I'm going to read the question, and we're going to try to kind of see some of those. We know it's a words of the equation. If we're starting to see that word rate in there, and we can answer the question, how fast? So when the height of the water is 5 feet, okay, well, that's just talking about a height of the water. So that's kind of what h equals. Height is increasing at a rate. Okay, so remember, we knew we had one of these things over here. If I replace that word rate with the words how fast, height is increasing how fast. That doesn't make sense. So remember, we kind of put those words up here, how fast, and really we turned it into the word rate. So the rate the height is increasing makes more sense. That's how we know we're using one of these, okay? And remember, whenever we see the word rate, that means that we need to do something with the derivative, okay? So we know that the derivative, the rate, we want the derivative at the, we want the derivative, or they're telling us that the derivative is 0.26, or there's a rate, the rate related to the height is 0.26. So I could write that down. I know that dh dt is 0.26 feet per minute, okay, because this value is related back to this. The rate in, what did this say? I didn't write it all. Using the model and from Part C. So we still need to use this function up here that we had in Part C, okay? Find the rate at which the volume of the water is changing. So how fast the volume of the water is changing, rates in the right place. We know that this rate means derivative, okay? So the derivative at which the volume of the water is changing, that's what we are supposed to be finding. So what we are supposed to, oops, I lost it. All right, what we are supposed to be finding is dv dt. That's our big question mark, okay? So that's the part that the setup piece like that, that's what I expect AB to understand at this point, okay? The rest of it for AB is going to be kind of a little bit, there's going to be some tricks in here, okay? So I know to get dv dt, and this is where BC, you guys are going to be able to understand, you should be able to understand this part, okay? To get dv dt, I only have things in terms of H. I don't have anything, there's nothing, I'm sorry, that wasn't what I wanted. Oh, actually that's the volume, right? Because our volume is right there, that was our volume equation. So I only have things in terms of H there, I only have things in terms of H here. So I don't have anything in terms of T. So I need to introduce an H into this equation. For those of you that are in BC, this is like how we broke it up for some parametric stuff. So we could say that we've got dv dh times dh dt, okay? Because all I did was really take dv dt and multiply top and bottom by dh dt, right? Or dh dh, which is equal to 1, and then I rearranged the order. This is a v. So it's dv dt, or sorry, dv dh times dh dt. So I just rearranged the order. I put this here and this up there, okay? Which I'm allowed, no, other way. I did this here and I didn't move anything else, okay? So I just swapped the order there, okay? So this is what we are trying to find, okay? And we're trying to find that at h equals 5, okay? So we know what this is, actually. We know dv dh is actually this equation right here, okay? It's actually the inside part of this equation, or actually it's this equation right here. It's this right here. So we're going to say that it is f of, but we're going to evaluate it at h. And then the dHdt stays dHdt. Okay. We know that we now need to plug in, because we haven't evaluated it yet, we need to plug in a 5 into this thing here. So I'm going to plug that in. So we've got h of 5 times dH dt at 5, which we know was this 0.26. Okay. And then again, that would, I have to go one more because I haven't evaluated this. So when I put all of that together and in a calculator, it would be 1.694419. Okay. If it didn't make sense, it's okay. All right. As long as you understood the setup up here and understood the words, we're good. You'd have to finish a sentence for that for the BC kids. The T kind of got turned into an H. So in that sentence frame, so we would say at h equals 5, the words of the equation was the volume of the water. It was right here. The volume of the water is, and it was a positive number, so that means it's increasing at a rate of this number, 1.694419. And then it was in, the measurement was in feet cubed, it was volume, so feet cubed per minute. Okay. I'm sorry that one was icky, but I don't want to just leave the icky ones off because we're going to have to be prepared for the icky ones. All right. That was 2017. All right. We're going to move on to 2019 now. So 2019 is up next. Okay. All right. So 2019 number 2 is where we are at. Okay, so everybody's back. AB, start paying attention again. All right. So the velocity of a particle p moving along the x-axis is given by the differential function v of p, v sub p, where v sub p of t is measured in meters per hour and t is measured in hours. Selected values of v sub p of t are shown in the table above. Particle p is at the origin at time t. Okay, so I didn't write that information down. I should have. P at origin at time t. What that means is that's an initial condition. Basically, the initial condition is that you have the point 0, 0, or f of 0 equals 0. We may need that later, okay? It's not going to probably affect a whole lot because it's 0, but it's possible we need that later. All right, so we are supposed to justify why there must be at least one time t for which the derivative of the acceleration of the particle p equals 0 meters per hour. Okay, so those of you that are in AB are probably going to have an easier time than the BC kids because I taught this differently this year. Okay, so this is one of the theorem problems. So it says justify, okay, and we have the must be at least one time, okay, in there. So remember we had to look at, I'm going to hopefully remember them, IVT, MVT, EVT, and Rolle's theorem. Probably not going to be Rolle's on the AP test, okay? I have the other three are probably going to show up, okay, or could show up, especially mean value and intermediate value theorem. So remember these ones, I think if I remember right, this one was the derivative. We have to do something with the derivative, and this one was a match, okay? And this one we had to have the integration, right? We had to be able to go one up, okay? And I think it was the same with that one. It had to be a match on this one, okay? So I'm looking at what they want me to get. They want me to get the derivative. I go to my table. Do I have a match in my table? Do I have a derivative and a derivative? I don't. I have a derivative and I have an original. So I know it can't be this one or can't be this one. So it's got to be this one right here. It's going to be MVT, okay? So I am going to, I know it's got to be mean value theorem. And mean value theorem says that I have to be continuous and differentiable. So I have to make those statements, okay? And then I have to show that the slope is going to be equal to 0. Typically part A, now maybe not this year, but typically there's a place in the Riemann sum problems where you're going to have to find the slope somewhere. I know it wasn't in the last one, but typically it's there. And usually it's kind of in a part A. So first thing, in order to use mean value theorem, we have to state that it's continuous and differentiable, which it said in the problem that it was a differentiable function. So we would want to say that V sub P is differentiable. Okay. And that implies that V sub P is continuous. Okay, remember this one means, that little arrow means implies. And it's continuous on, they gave us an interval that was continuous on. It was 0.3 less than or equal to t less than or equal to 2.8. Okay. And then what we need to do is we just need to do the slope calculation, okay? We need to use these x value or these x values. So I need to find the y values associated with those. I typically go with the bigger one first, or the one further down the line first. So I'm going to, on 2.8, it's 55. And then my other y value is another 55. And then my x value is the 2.8, right? And the 0.3. And we get 0 over some number. I don't know what the number is. Don't write that on the AP test. So basically you just need to say that it's equal to 0. Because you know 55 minus 0 is going to be equal to 0. So that was your proof. Or that was, you need to show that. And then you would want to say that by, and you are allowed to abbreviate mean value theorem, by MVT, there is at least one value. And I'm not sure I'm using the sentence frame we did in the class. There is at least one value C on, and you can use the brackets or you can use the inequalities, doesn't matter, such that, I'm basically restating their sentence, such that V of P prime of C equals 0. I'll give you a minute on that screen. Okay, I'm going to keep going. So we have, next one says that, so I'm reading part B. Use a trapezoidal sum with 3 subintervals, and they actually gave us the 3 subintervals because you'll notice that your problem has more than 3 spaces in the table, okay? So 3 subintervals to approximate the value, and they're wanting us to approximate the value from 0 to 2.8 of v sub p of t dt, okay? All that a Riemann sum is an approximation of an integral, so you can label it like this. That's how you want to set it up, okay? So I'm going to go look at my table here and look at these subintervals, and I'm sorry, I'm going to have to scroll a bit. Okay, let me use a different color. So here's subinterval 1, subinterval 2. What happened? I did that wrong. Subinterval 1, subinterval 2, subinterval 3, because I'm going from 0 to 2.8, okay? It is trapezoidal. So trapezoidal means that I'm going to set up for 3 trapezoids, okay? Which means that we know when we have a trapezoid, we know we divide that formula by 2. And we know we've got to do, kind of setting up the skeleton. It looks like that. This is our base sub 1 plus base sub 2 times the height, okay? And the height is going to be the distance in between. So what goes there is the distance in between the x values, okay? So my heights, I'm going to do my first height. So it's going to be this height and this height. So what I'm going to do is 0 and 55. And then we need to do this distance in between, which is going to be 0.3. So times 0.3. Okay. Then it's going to be this height and this height. So the height repeats. Remember, we've got those trapezoids are jammed up next to each other. So 55 and negative 29. And then I want this distance in between, which of course I did not calculate. Let's see if they've got it from, okay, it looks like it is 1.4. Okay. And then I'm going to go one more time up here to my table. Sorry, and keep scrolling. Use a different color. This height and this height. So negative 29, it repeats, and 55. And then the distance in between, so I would say distance in between those two numbers there is going to be 1.1. And right there, don't make the calculation, stop. Okay? You've only got 25 minutes. These questions are only 4 parts. I'm going to estimate that in the 25 minutes, it's a 7-part question. Okay? That's going to be my guess. I don't know if I'm right or wrong, but that's going to be my guess. Okay? So that's where we've got on the, so I would stop there. If you really, really want the final answer, okay, and you want the numeric answer, it was 40.75. Okay. There wasn't any label. It didn't say, you know, to make sure you indicate units of measure or anything. Okay. All right. So here's what I want AB students to do. I told you to go to find 2009. Okay. So find a 2009. All right. And it's 2009, number 5. I want you to start with part C. So start with part C because it's a left Riemann sum. Okay. Then I want you to go ahead and I want you to try to do A and B. Remember, derivative is just another word for slope. Okay. So everybody in AB, go find those problems and start doing that part. We're not going to look at part D at all. Okay. So we're just going to look at A, B, and C. But I need to go through the other part with the BC kids and the other 2 parts here. And they, these 2 are not on your test this year. So we're not going to, I don't want you to even worry about them. Okay. But I'm going to real quick go with the BC kids. Okay. So if you're in BC, you're still paying attention here. I'm looking at part C. I've got a second particle Q that also moves along the x-axis. So its velocity for 0 to 4 is given by this equation right here. Okay. And they did say something which I didn't write down, which was there is an interval from 0 to 4. Okay. And it says that this is for the time interval. So find the time interval during which the velocity of the particle Q is at least 60 meters per hour. So that's why I wrote this, because it's got to be greater than or equal to 60 miles per hour. You're supposed to find the distance traveled. Okay. So the distance traveled by particle Q during the interval when the velocity of the particle Q is at least 60 meters. I'm sorry, I said miles. That should be meters, not miles. Meters per hour. Okay. So when we have total distance, it's what you're really doing is you're finding the integral of the absolute value of the function. Okay. Or integral absolute value. Okay. So all you really have to do is we have to, so we're going to integrate the v sub q of t, okay? And we need to figure out, and this is the tricky part, which I didn't really look at ahead of time here. We have to figure out what the values are for a and b. And again, this is a calculator problem, so I'm not going to go into huge detail. I'll just tell you what to do. What you would do is you would take this guy, and you know that it's at least 60 miles per hour, and you're going to set it equal to 60. So you would do 45 square root of t cosine 0.063 t squared, and you would set that equal to 60. It's not going to be a calculator problem this year. So this would be something, if it was on this year's like this, it would be something that you would be able to do by hand. Okay, so like you'd have to factor to get those values. In this case, you would put this into F1, you'd put it into Desmos in the first line, put this one into the second line, and then find their point of intersection. Actually, there's going to be 2 points of intersection. Okay, those will find you your bounds or your limits on your integral. So the numbers that they got were 1.866181 and 3.51974. Okay, and then when this one, they did integrate it in the calculator. Again, you can't really do that. This wasn't a great example for this year, but at least you can kind of see the setup. So 106.10874. Okay. All right. I'm going to keep going. So again, this one's not on the AB test. So we've got that. Let me read the problem. At time t, particle q is at position x equals -90. Okay. So that was kind of an initial condition right there. Okay. And this is q, the information for q. Using the result from part B and the function v of q from part C, approximate the distance between the particles p and q at t equals 2.8. Okay, so we need to know what the position is of particle p and particle q. So I need to find, that's just notation, x sub p of 2.8. So the p function was way up here, and what do you know? Look at that, right there. We actually have that answer right there. Okay, so we don't even have to do any extra work for p, we've got it. Okay, so that's our position, because this would have been the velocity, that's the position, we're going to go back up to that. Okay, so I know that, where did it go? There it is. All right, from 0 to 2.8, v sub p of t dt equals 40.75 is what we got. Okay, now I got to find q. So x, just notation, x sub q of 2.8, which means I know that I've got a q function from here, but it's a rate, which means if it's a rate, I need to integrate it to get it back to position. It's like it's a velocity. So I'm going to integrate, notice I left a space in there, 0 to 2.8 of v sub q of t dt. But we had this guy right here, we had that initial condition that we've got to take into account. So I know that we're starting at -90, that has to go out front. And then when we integrate that, and again, with the calculator, you would do that integral. And on this year's test will be something that you could integrate by hand. They got 135.9376, and it was 45.937653. All right, AB kids, we're back on. Pay attention again. This is the last one I'm going to do. Okay, we'll try to get through it. So, weird buttons. Okay, so I went and pulled a 2009 for you guys to kind of try on your own while I was doing finishing up the BC kids. This one should be significantly easier. I'm hoping they go a little bit easier on you guys this year, given the nature of the test and the situation. So this is what it used to look like. I don't know, that was a long time ago now. It's like it's like 10 years ago plus, 11 years ago. So it almost always was traditional. A was find the derivative, and then somewhere down the line was some kind of a Riemann sum. Okay, so we've got a function f that is twice differentiable for all real numbers. The table above gives the values of f for selected points in the closed interval from 2 to 13. So we know it's a closed interval from 2 to 13. We are supposed to estimate f prime of 4, show the work that leads to your answer. So if you ever see this and you've got a table, ooh, you say thank you because it's an algebra 1 problem, because all you need to do is find the slope, okay? Use these endpoints. So those are going to be your x, those are your x values. It tells you right there, those are your x values. So x, remember, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The calculus part is knowing that the derivative is the slope, okay? All right, so I'm gonna put f prime of 4 equals my y value. So my y value at 13 is 6. My y value at 2 is 1, so 6 minus 1. And then we've got 13 minus 2. And literally you could leave it like that, but I know some of us need numbers. 6 minus 1 is 5. 13 minus 2 is, I'm doing something wrong. F of, what happened? Oh, f prime of 4. I messed up. Let me fix that. Let me go back to again. Okay, it wasn't 13 that we were looking at. Okay, it said f prime of 4. So when I have f prime of 4, what I need to do is I need to find, because it said this, I need to find numbers that surround the 4. So 4 would be right in there. So on the table, the numbers that surround 4 would be 2 to 5. So those are the numbers I'm going to use in my slope. Okay. So my y value that I'm going to actually use is negative 2. I'm going to subtract the 1. And then I've got 5 minus 2. So negative 2 minus 1 is negative 3 over 3, which is something still wrong. What did I do wrong? Oh, it's a positive 1. So minus a positive 1. That's going to make it negative 1. I'm still doing something really wrong. Connor, do you see what I'm doing wrong? I'm supposed to be getting an answer of negative 3. Oh, it was f minus. I know what I did wrong. I'm sorry, guys. I blew it. I shouldn't have used this. I should have been using the 3. Okay. We take the two numbers on either side. And I apologize, I'm having to do this problem 6 times. The easy one, I'm messing up. I can do the hard ones. All right. So it's the number on either side. So it's negative 2 minus 4, and then 5. I'm still doing it wrong. What is it's too late in the day apparently for calculus. I needed 0 period. All right, so we got 5 minus 3 over negative 2 minus 4. 5 minus 3 is 2. Still not coming out right. What's going wrong, Connor? What am I doing wrong?
Flip it.
The y's on the wrong side.
Yeah, 5 minus 3 is on the bottom.
Yep. Thank you. And they're screaming that a child needs to go potty in the background. Isn't that nice? All right, there we go. 5. Now I think I finally have it after 6 tries. All right, negative 2 minus 4 is negative 6, and then 5 minus 3 is 2. So now we finally have the right answer of negative 3. Again, leave it here. You don't have to simplify it beyond there. As soon as it's numeric, you're done. And that would be a huge, huge, huge time saver. Okay? All right. So in part B, you know how we have all the rules. We've got product rule, quotient rule, chain rule. This is how they're going to test that on the AP test, okay? Or some of the basic properties. The property where we have if the 13 was down here and the 2 is down there and you've got to flip it. This is how you're going to see it tested. See how it's just thrown into this problem kind of in a weird random place, okay? So all we have to do is literally evaluate that, and this is a gift right here, and you're probably going to see stuff like this year because you're not going to have the multiple choice to do this for you, okay? I'm going to split that into 2 separate integrals. So 2 to 13 of 3 dx minus from 2 to 13, and I'm going to put the 5 out front. We're allowed to float that out front, and then f prime of x dx. Okay? All right. Then we're going to go ahead and integrate this here. And when we integrate 3, we've got 3x, and we're going to evaluate that from 2 to 13. And then I'm keeping the 5 out front. When I integrate an f prime, I've just got an f, and then from 2 to 13. Okay. This I'm going to plug in. So I've got 3 times 13 minus 3 times 2. Then I'm going to subtract super big parentheses. Okay. I'm going to keep that negative 5 in there. So it's negative 5 times f of 13 minus negative 5 times f of 2. Okay. Well, where are these things right here? They're up here in this table, okay, which I've erased part of. So f of 2 is 1 and f of 13 is 6. So we're going to go ahead and plug those in. So this was 6 and this was 1. And literally right here, once you've got it there, 313 minus 3 times 2. They don't want to see you doing arithmetic. And I've seen this emphasized in the videos from College Board. Stop here. Okay? You really have to keep going. The final answer is 18. Okay? All right. Finally to the one that we were looking for, because this is the theme of the day, is Riemann Sum. So we had to do a left Riemann Sum. Let's see if you got it right. Okay? And so the problem says use a left Riemann sum with subintervals indicated by the data in the table to approximate from the integral from 2 to 13 of f of x dx. Okay, show the work that leads to your answer. So we don't have to explain it, we just have to crunch it out. And if we look in the table, okay, we have 1, 2, it said the 13, 3, 4 subintervals, it looks like. Okay. Oh, no, wait. 2 to 13. Yeah, that's right. Okay. So we got 4 subintervals, and it didn't say with, it just said with subintervals. So we don't have any particular number they want us to do. All right. So that means I've got 1, 2, 3. I make 4 spaces. Okay. So left means I'm working from the left. So I'm sorry, I have to keep scrolling. So we're going to use this. I'm going to use a totally different color. This height and this distance in between. So 1 times 1. Okay. And then we've got this height and this distance in between. So 4 times 2. Then I've got this height times that distance in between. So -2 times 3. And then we've got this height and this distance in between. So 3 times, I'm losing it, 13 minus 8. Andy, what's 13 minus 8? Oh, 5. Thank you. The second grader answered for me. All right. Then again, you stop here. Okay, don't go on. But the final answer is 18. Okay. All right. Are there any, before I go back to my camera, are there anything that I missed or you guys want to go back over? Nobody asked any questions. There's one comment in there I'm seeing pop up, but nobody popped in with any comments or questions. I'm losing, my camera's in a weird spot. Oh, Connor tried to help me out and I wasn't watching the comments. All right, so.
Are we able to use the microphone?
Are we what? Yeah, go ahead. You can use the microphone. Okay. Oh, Johnny, you're here. I was going to play your song today, but I missed you guys in class too. But you weren't here in the first 15 minutes before class. I was going to play your Big Time Rush song. All right, who was asking questions? I'm sorry.
It was Gabby. So for the part A, when you did the y2 minus y1 and x2,
yes.
So how come we didn't do the 2 and 1, like the left side of the
left side there? Okay, so Let me find a totally different color here. Okay, let's use this. It's sparkly. Maybe. Come on. All right. So what we had is we had to find 4, and this is where I totally just messed it up and it's not writing anymore. Let me try this. Go back to this. We had to find 4 on that one, and now it's not doing anything. Come on. No, it's not letting me do a pen. My thing stopped working. There it goes. Okay. Or not. Give me a pen. It doesn't want to write right now. Why is, okay, so it wanted us to do, oh, that's just my finger's not working. Now my thing's not working. Maybe it's the mode I'm in. So I'm gonna have to explain it without writing on it right now. We wanted a 4, okay? So they gave us this 4 right here. I can't even point right now. Let me see if I can get my mouse working. All right, so they wanted us to do it with a 4. Oh, look at all the weirdness that's happening now. They wanted us to do this. They wanted us to do this 4. So what you have to do is you have to pick the numbers on either side of 4. And it's because it's the first one I've done this year. I don't know why. It's been a while. I forgot. So the numbers on either side of that 4 are 3 and 5. So I'm going to pick the x values of 3 and 5 instead of the x values of 2 and 13. Does that answer your question, Gabby? You can just give me a
So you
go ahead.
said we don't do the 2 and 1 because we're just working with the ones to the right?
You're working, so because it's the estimate asked us for 4, okay? We want the numbers, the x values that are surrounding the 4, the closest ones to the 4. So the 4 is between 3 and 5.
Oh, okay, yeah.
Okay.
Thank you. Yeah.
Welcome. All right. Any other questions, concerns about any of it? I'm going to look at who's here really quick because I kind of have been keeping track. I see Michaela. Some people came in late. All right. So I do have a little bit, I have a time for tomorrow. My schedule tomorrow and Monday are a little bit tighter because I've got other things, unfortunately, I'm going on. What's extra credit? Oh, if you're here, I don't know, maybe I'm keeping track. I'm trying to keep track at least. So that would be nice for me to give you extra credit. I can't give you extra credit though, right? I can only give you, what is it called again? I'm losing. Enrichment. Thank you, second grader. I can only give you enrichment. So enrichment points, maybe, if we show up. Maybe I should start doing that. Maybe more people would come. What do you think? Maribel says yes. All right. Honestly, Michaela says she forgets how to do math. Yes, thank you for being on time today, Nate. Okay. I'm sorry you have to work, Johnny. All right, I'm going to turn off the thing here. All right, I'm not worried about you guys being late. It's not. Let me see. Presentation. You are presenting. Stop presenting. Okay, so let me look at I got to find my phone because I have the time in my phone for tomorrow and Monday. Let me tell you about that. If you came late, I made an announcement at the beginning that I had the date wrong for the test. It is actually the 12th, not the 11th, in case you watched yesterday's. So for tomorrow, okay, is everybody listening? Write this down, 2:30 to 3:30. I'll send out an email here in a few minutes, but tomorrow is 2:30 to 3:30, okay? I'll probably do tomorrow, my plan was I'm going to kind of do one of each type in the next like week and a half. And then if we decide there's one we want to focus on, we'll do that. I made that Wakelet board. It's all attached in Power School. I'm kind of going through the first 2 that I actually kind of gave you some ideas on studying. And then I will add some more study in the next couple weeks and finish updating that Wakelet board. Okay. And then Monday is going to be, and Monday is super tight for me, is going to be 4 to 5. So Tuesday or tomorrow's 2:30 to 3:30, and Monday is 4 to 5. All right, and that's as far as I have planned it this week. Please make sure you are watching watch the College Board stuff. Okay, it's really good stuff. Okay, if you haven't been, get them done. If you can get them done by tomorrow, I can get all that extra credit in over the weekend. All right. Oh, and I said I would do. Actually, you know what? This week. Let me think about Saturday. Let me see how tomorrow goes, and then I will think about Saturday and maybe do something Saturday afternoon, maybe around the 3 o'clock hour on Saturday. Okay, I gotta clear that with my husband. All right. Okay, I am 5 minutes early, so it's like you guys could stand up in class and go line up by the door like you're not supposed to right now. Okay. Thank you for smiling at that, Madison. I appreciate that. Okay. All right. I gotta laugh out of Lorenzo too. That's awesome. All right. So since Johnny's here, I think we have to put this on because, you know, it's his favorite. Or did he leave on me? Extra credit isn't technically due tomorrow. I will take it still after tomorrow. But if you want it in for this triad, I have to have it by tomorrow at 5. I'm going to start trying to cut grades tomorrow after 5. Okay. All right, here you go. For those of you that aren't in 5th period, this is what 5th period's like. And of course, tomorrow we will have the Friday music. It's worth coming just for that. Bye, Nate. Gabby, I don't know when the semester grades are due. It's probably at the regular time. Okay. Lorenzo, let me talk about enrichment points. I'm not allowed to call out extra credit anymore. So I have to call it enrichment. It's basically the same thing as extra credit. So at this point, any points I put in beyond the homework that was already due have to go in as enrichment, which is extra credit. Okay? I just can't call it that anymore. All right. Any other questions? Yeah, I know. Big words for extra credit. Okay. Any other questions? Nikki, tomorrow is just the triad grade, not the last 3 for the year, so you guys can still work through stuff. That's what I can't call it extra credit because that's what I've been told by the principal, David. All right. Anything else? I'm looking through the chat really quick. All right. All right. I'm going to see you guys tomorrow, hopefully. I will have Andy practice for the AP exam. He does arithmetic better than his mama. So, you know, I will. He refused to do, since we've been home doing homeschool, he's refused to do any 2nd grade work, even though he's a 2nd grader. We've been doing all 3rd grade stuff. His 2nd grade was just too easy. So if we have to homeschool much longer, I'll have him doing calculus in about 6 weeks. So. All right. I will see you guys tomorrow. I loved seeing all your faces today. So, no, don't feel ashamed. He's just weird. So, he's been over here listening the whole time. And don't forget, all of my children have already taken calculus 1 time because they took it while they were all in my belly. So, they've kind of got an advantage over everybody else. Madison's just smiling. All right. Thank you guys for coming, and I will, yes, they are elite, Michaela. All right, I will see you guys tomorrow, okay? You're welcome, you're welcome, you're welcome. All right?
Yeah, somebody asked me to do